My name is Tessa Jones. I am a data scientist and research scientist, building machine learning and AI algorithms for a plethora of different companies. Also, doing research and development in that space to help optimize what we get. And really excited to start this podcast with Sophie, um, who's amazing, and I love chatting with her. We figured we have these great conversations. We might as well share. So that's me.
Uh,
Happy to be here.
Cool. Uh, Sophie Chase Borthwick. I'm a data ethicist because it's such an exciting space, and likewise, talking with Tessa about all the progress and things that are going on amazes me. And then the little part of my brain in the background that's the ethicist is going, hang on, but what about?
I think that, just to give everyone kind of an idea of why we're here, how we got here, and what we care about, it might be obvious, but, we're really interested in providing an open space for just, discussion between Sophie and I, but around AI, machine learning, how it's used, the philosophy behind it, and then really the intersection between that and ethics and privacy, and all of the encompassing components of all of that. And I, for one, was motivated to do this podcast because I think there's just so many very important topics in this arena that really could benefit from a space that isn't hindered by any restrictions. We're just here to talk openly about these topics and their usefulness in conjunction with the risks, and just being really open and honest and explorative in nature.
Absolutely. There's a lot of conversation about AI, and a lot of people come into either the camp of AI, it's awesome, it's going to solve all the problems in the world, or AI, it's evil, we're going to create Skynet or the Matrix. And
Yeah.
as with pretty much everything else, it's going to be somewhere in between. There's what it's used for, how it's done, but the impact these things have on people and society at a wider point is important. And, we wanted to have that chat to try and understand if we, even never going to come up with some conclusions, but at least understand what the discussion is and the things that need looking at and considering.
Okay, so Sophie, we're here today to talk about when is AI actually intelligent? Yeah?
Indeed, which it's been in the news a lot recently, and there's an awful lot of opinions in one way or the other. But putting aside the specific case in the news, let's discuss it a bit more generally.
Yeah. So I guess a good place to start the conversation is to kind of lay a framework, some definitions that we're going to align on, and all of that jazz, because I think it's important. Because honestly, like the number of definitions that I've seen for what AI is so broad, let alone intelligence within the AI field. So I'm going to level set this conversation with a couple of definitions. So first, just AI in general, which, honestly, for the sake of this, I'm going to just use the most broad definition that I've seen, which is honestly quite astonishing. This definition, because essentially it's defined as systems or machines that can perform tasks commonly associated with intelligent beings. And I don't know how much more vague you can get than that. But under this guise, even computers would probably count as AI, generally speaking. And so, that's a very, very broad term. And then if we kind of take a subset of that term and talk about intelligence within the space of AI, um, we probably define intelligent broadly as problem solving and artificially intelligent systems as taking the best possible action in a given situation. Now, if that leaves, a lot of questions about what any of that means, what is problem solving and what is the best possible action? Like these are very difficult things to kind of nail down concretely. So, but that's, I think, the framework that we're going to work within this conversation.
We've gone with a very broad definition. Now, we know that when people talk about artificial intelligence, they're not actually meaning your old mainframe doing its rather hardcore stuff.
Yes, definitely.
So, yes, that's in the broad, but in common parlance, how do people tend to think of it?
So, yeah, let's get a little bit more concrete. So, I'm actually going to make two more definitions that I think help corral this conversation a little bit, because actually there's debates around what intelligence is, and is artificial intelligence by definitions of intelligent even possible? And so I think it's important to kind of talk about this in two different ways. So the the majority of the AI we actually see in the industry and in the field is what we would call narrow AI, which means that it has a single task. You're building a system to perform a task, and it can learn and it can execute on that task. Now, you might build lots of narrow AI systems that work together, that perform many tasks to have a larger task that they're all doing together, but still they're all within this narrow AI because they have a well-defined task, and they can learn that given task. General AI, on the other hand, uh, is a lot more broad. It's basically intelligent machines that can comprehend, learn, and perform intellectual tasks much like a human. So this is getting into the arena of a little bit more of the fuzzy territory, and I think where we're going to spend most of our conversation today, because it's a lot more ill-defined. Because what does it mean to act like a human? What does it mean to perform a task like a human? Um, and I think a big part of that is even being able to naturally live in the world like a human, build tasks like a human, um, execute tasks like a human, so on and so forth.
Yeah, and by execute tasks, we don't necessarily mean literally you have to have fingers and toes and eyes and a mouth, um, because
Right,
we're not talking purely the old school Android.
right.
It's as much the problem solving as anything else, and that learning capability.
Exactly. Yeah. So then, right. And so within general AI, I think there's broadly like three categories you could talk about. There's the capacity to learn, which is what you're pointing to. And we could talk about that in two different ways: rule based learning versus experience based learning, which, we can go into. But the other two, you have to be able to uh, have the capacity to learn. You have to be able to develop concepts. So, from what you've learned, can you turn that into a general concept that can then be used later, which is actually fairly difficult for machines to do. And then
Which is
lastly, there's different components of uncertainty, and like subtask development or generalization, and there's a whole other arena over there that's also very important in considering what general AI could be if we ever got there. um,
so I'd like to talk about the conceptualization a bit, because one thing humans are quite good at is, from not a lot of data, seeing something else is similar.
yes,
Uh, the example I've talked about before is dogs. We know
yeah.
that things are dogs and things are cats, and if you were asked tangibly, if and you're not a biologist, to say, well, how do you know that this is a dog, be it a Great Dane, a Chihuahua, a Chow, versus this is a cat? It's quite difficult to articulate, but even small children will happily go, "That's a woof woof."
Totally. Yeah. Yeah. Right. Well, and I mean, there's a couple of different ways we could kind of tackle this piece of it, because for true concept formation, literally, you're just observing the world, and it's, like based on the experience of living in the world. Not, as when you're a parent or when you're a kid, oftentimes the parent will, go through and label a car, but they're not going to say car every time you see a car, right? But, they have all this, the child has a lot of context to work with in order to identify that these things are cars. And that's really important for concept formation. And in very technical terms, this would be like an unsupervised machine learning program where it's got a bunch of context without a direct label for every instance that is a car or considered a car in this example. And that's just it's a harder task to fulfill from a machine perspective because there's a lot of context that machines just don't have that a human experience does. Yeah,
Um,
and I know they're doing some interesting stuff now in image recognition where they're trying to extract textures through images, right? Which goes into this whole arena of the capacity to learn around perception, which I think is quite an interesting area when you think about the difference between humans and machines, because humans, we have touch, we have smell, we can sense temperature changes, and the sensors, even on robots, they're fairly limited. And then not only are the sensors limited, but then the algorithms to perceive the sensors information is limited.
so
And
are we
so
saying machines are even more susceptible to wolf in sheep's clothing than the literal sheep?
yeah, I mean, I think so. Right, yeah,
Because
that's it.
if we're talking about the textures, etc., rather than I've just got this vision of someone in their sheepskin, and the AI magically thinks they're now a sheep.
Yeah, for sure. Well, and then I guess, maybe the robot could, see the image and say, oh, well, I do identify a sheep. I identify the texture, but I can't hear, maybe the sound is, I don't know, or the smell or the temperature or the just general sense of it would be missing. Maybe. I mean, there's a lot of advancements in robotics where a lot of that they could do if they really wanted to, but you'd probably have to be fairly focused on that objective.
So we're talking a lot about the learning capacity here,
Right.
but we swap it away from the artificial and we talk about living things, as it were, humans, animals. We tend to think of intelligence in terms of sentience, in terms of consciousness, um, and even self awareness, depending. And it seems like those concepts that we use for said humans, animals, we're kind of skipping over to make intelligence fit with machines.
Mm.
That I mean, this is touching into sentience a bit, the learning, but the consciousness and the self awareness, we're seeming to decide that no, we're going to gloss over that. It doesn't really apply to machines, so we're redefining intelligent.
Sure. And I would say that the way that self-awareness and consciousness, at least in what I can acknowledge is within the playing field now, is kind of a couple of examples. So actually, um, learning like physical. So how I was talking earlier about rule-based learning versus experience-based learning.
Hmm.
So most classical AI is within like rule-based learning, where the system has a set of input rules and it learns within the realm of those rules, right? And that is very much, I agree. Like, not, you don't have to have self-awareness to execute that. It's fairly rudimentary in some sense. And we've gotten really good at that. But then there's this experience based learning, which is really going on with a lot of robotics, where instead of programming, they're actually teaching these robots through experience. And one of the hurdles of that is, okay, so I'm a robot. I'm like, let's pretend I'm like a cylindrical robot similar to like R2D2. I don't have any appendages, but my human is trying to teach me how to kick a ball, and the human is kicking it with their foot. I have to adapt around that to understand what's the objective I'm trying to learn. How do I kick a ball without a foot? And you could maybe make an argument that there's a level of self awareness needed in order to execute that. Um, to kind of work around that.
I mean, on the one hand, yes. On the other, back to the dogs. They figure out how to play football. They don't do it with their feet.
Yeah, that's true.
But they learn how to interact with the human, move the ball around. Now, there's a whole bunch of things on dog intelligence, and we've gone into animals, but I'm finding it interesting that we're kind of separating how we define intelligence into human, animal, machine. And surely if machines are to be considered intelligence, you're going to have to bring those other concepts rather than coming up with a new definition of intelligence that fits
Sure.
what we feel. Actually, this one's an interesting thing in itself, in that in the EU, animals are considered sentient.
Right.
There's laws passed. They are considered
Certain animals,
sentient
though, right?
beings.
It's specific animals, yeah.
It is, but it's certainly pets. It means that they have certain protections because they're now sentient beings.
Right.
But also, we all know, cat owners know, dog owners know, that they learn. They learn us. They show behavior accordingly. They have that general behavior we were just saying is so very difficult for AI. A lot of animals learn inherently. Certain crows have the intelligence of your average 7-year-old.
So how is the line around that drawn, if at all? Like, because I'm imagining, like, my
Well,
son
and
had
this
a
is actually
goldfish
part
at
of the
one point. Is the
conversation
goldfish
in.
considered sentient and intelligent? Just curious how the lines are drawn there.
In fact, goldfish are a whole conversation because you can teach them, some of them, tricks.
So is that part of the definition, is being able to learn?
But yes, absolutely. Part of that is the learning that we were talking about. And this is where the learning for animals is much more akin to the learning for children than the very specific rule-based that you were talking about for the machines. In fact, we know that children don't react well to pure rule-based just because it doesn't tend to work.
Really?
You can't tell an animal that you have to do something just because they have to do it. You can.
Sure.
Now, they will learn positive reinforcement, they will learn negative reinforcement. Now, we think of those as rules, but they're not really rules. They've learned that this behavior gets this outcome good, I'll do that more. This outcome bad, I won't do that.
Right.
No point do we say to the animal, because I said so.
Well, and that gets into an interesting topic, where there's a little bit of overlap here, which is motivation. So I know, like, when I train my dogs, they're massively motivated by food, and that is like, I can get them to do almost anything if I have food. And that's interesting in itself, right? Which brings up, I know within the world of AI, motivation that's kind of at the root of what you brought up in the beginning, right? Are we going to have, like, robots take over the world versus, a truly harmonious sort of outcome with AI? And I think that's kind of at the root of it, right? Is this idea of motivation, like, what actually motivates the AI to do anything, to build a task? And that gets into a whole, other area of,
It is,
you can
and
talk about specific motivations or sort of abstract motivations, maybe even emotions.
some of that, the definition of intelligence is that abstract motivations. Now, not every, because there are as many definitions of intelligence out there as you want to use, but quite popular ones to differentiate humans from animals is those more abstract concepts and motivations. The whole Descartes stuff, which I don't like to do this word elevate us, but that's the term often used, that is what's different about humans, that our motivation isn't just those basic safety items on the hierarchy of needs. We go up the pyramid.
Right.
And have those further
Sure.
motivations. The AI, the narrow, they don't even have the concepts, But the general, I'm struggling to see how that ties in with those more human definitions.
Yeah. So, well, to give an example of, well, we're not at general yet, but there's this nice spectrum that we could talk to around the socially assistive robots that are coming out. So in Japan, they're doing a lot of research on this. And they're basically mostly robots that are intended for like assisted care. So, like caring for people who can't care for themselves, or people in hospice, or, people that just need care. And one of the things interesting that I read recently was this concept coming out of Japan, who's developing most of these right now, at least, is this concept of kokoro, which is basically that in order for these SARS robots to actually be effective and useful, there needs to be a heart-to-heart connection between the human and the robot. So they have this concept, and then they broke it down into basically three different kinds of kokoro that you could achieve with a robot. So the first one is literally just the robot that affects the human. So it can affect, if a human is feeling sickly and like really depressed, the robot can interact with the human in such a way that maybe lifts its spirits or maybe makes it feel a little bit more comfortable. Then
Okay,
there's like,
but whilst that's good, I'm not sure that requires intelligence because we will imbue emotion onto a toaster.
I agree. I agree. I agree completely. Yeah. So, and that's why he built it as a spectrum, because then the next one is uh, that the robot understands the human emotions. So, yeah, in the first example, they maybe made the human feel better, didn't mean they understood it at all, right? So, in the middle one, they sort of at least conceptualize what when a human's feeling sad or angry. And I mean, there's all kinds of issues with that. I know one of the um, Microsoft recently stopped a lot of its programs around emotion detection because it's not accurate. It's difficult, right? And it introduces all kinds of biases. Differentiating between anger and happiness is actually harder than you would think based on imagery or voice. And so,
And people display anger differently.
yeah,
There's a whole gendered conversation I'm going to skip over here,
sure,
but uh, the classic display of anger, of the shouting semi-aggression,
right.
doesn't carry above across the board. Some people just shut down, some people get teary, and the Microsoft wasn't handling some of those differences.
No, it wasn't. And it wasn't, and yeah, and it gets into also racial lines
Yep.
because, different, that's due to both available data as well as like different facial features, voice features, things like that. Yeah. But so of the Kokoro concept, there's the three. The last one is actually that the robot itself feels. And to me, this is so interesting because I feel like the first two, yes, it's maybe kind of interesting, and even the robot being able to perceive feelings is interesting. Like if they're able to successfully perceive emotions, that is interesting. But like there's something to be said for maybe intelligence around actually interacting with another entity that feels itself. Like feelings is one of those things where it's like, okay, I identify that you're angry, but I don't know what angry is.
Well,
And
and but this is also interesting because if we're defining that that's what's required to be considered intelligent, we know there are some um, issues in neurodivergence where they don't recognize emotions. So, by
right,
saying this emotional recognition is a requirement for intelligence, we have to be very careful not to carve out some humans.
no kidding. Well, and that actually aligns a little bit with what I was just thinking, because to me it's like even if they can't recognize it, they feel. I guess there are also humans that technically don't feel. What is the what
I
forget the terminology.
There's a whole bunch of diagnostics on the certain personality disorders feel.
Right.
Are there motivations on the emotional side of things, or is it purely actually quite machine in some ways? So
Right.
again, this
Well,
is
that
one
is
of
so
the
interesting. Yeah, because if you're getting to the point where you're having to carve out certain people in order to have a proper quote unquote definition of intelligence. Yeah, and I think that gets back to almost like the side of this that I find very compelling, which is just the general experience of being a human or an animal even, right? Like where you have full body sensories and you're just living in the world, including when you're interacting with information or another human, you have a whole host of senses that are being elicited. Um, that is,
and the
and,
concept of
there
sentience.
are people who are trying to do brain mimicry, replicating the brain, but then there's the body too, right? And I know that's like sensors are getting into it, and I
Well,
just
we were
question
talking about the
how
crow
well that is
briefly.
able to be replicated.
Yeah, we were talking about the crow briefly. It has a totally different brain structure to humans, but we know that they're intelligent. So it
Right.
can't just be to do with how the brain is done. But it's also why I hark back to the children concept, because of the way they learn, of the way they pick stuff up, of the way, and they're not necessarily reading stuff and having the mass data fed. Well, except they are having mass data fed to them. It's just all around.
Right.
And that's the bit that amazes me, that something that's really easy for a child to understand, but we're redefining intelligence to include a machine in it.
It'd be interesting if you created a robot that played chess that was also reading the humans' emotions, incorporating that into the play. I don't know.
So even if we stick to the play, if you, with your understanding of how AI works at the moment, if you taught, and we have taught obviously, an algorithm chess and they became really good at it, how easy would they find it to transfer that to, say, checkers?
The way it works right now, it doesn't work that way. You can't transfer the task because it's a task. So, and
Mhm.
that's one of the interesting things about, the difference between general and narrow AI is task formation. So in general AI, you're learning your environment and your world, and you're actually building new tasks. And that level of intelligence is questioned, like the intelligence of changing your objectives on the fly like that and learning experientially. Although I could be wrong. I don't know the depths of that level of research for robotics, which the stuff that they're doing is so cool, right? Where it's like it's literally, and when you look at the pictures of it, it's kind of funny because you see these robots that are in these like gym environments where they're like trying to learn how to do something through repetitive actions, and they are getting like pretty good at that. It's mostly like physical activities, like moving things around. And so there is a lot of advancement in that space of the learning through experience process.
Let's go to the other side, Mike. Let's face it, I'm a Brit. Making a cup of tea.
Yeah. Right. So I think there are lots of labs out there that, or lots of labs. There are robotics engineers who are building robots for things like that, like going through the process of, so the classical way of doing it, that would be more classic programming, is you literally go through all the possible steps of how to make a cup of tea. So you would say, okay, the glass, where it's going to be found, and you have to code all the conditions if your cup is going to be found someplace slightly different. Or okay, so but then that's the first step of taking a cup, and then you program step by step what you do to make a cup of tea. And then experience based learning, actually the person teaching the robot actually like demonstrates how to make a cup of tea. And then when it breaks or it doesn't do it well, or something's misplaced, then and it doesn't do it correctly, it just does more examples of how to fulfill that task. I'm sure there's ways you could, but there would be super limitations, right? Changing the environment would be difficult.
Well,
Yeah.
and that's, I guess, kind of what I'm going with. I picked that as a personally British, so we all make cups of tea all the time. Yes, the stereotype is true.
Yeah.
But also, it's actually a lot of steps. If somebody says, I like mine a little sweet, I like mine strong, I like mine weak, a dash of milk or a splash of milk, which is, by the way, different.
Right. And then in that case, you'd have to, right, you'd have to have the ability to tell the robot what your preference is, interpret that preference, and then execute it within the learning experience. And I guess you could theoretically if you went through that in your process
Uh,
of
But
learning, right?
if
Where
it's all of those individual, but so far we're still going with the task and task and task and task.
right.
We're not saying that there is a level of intelligence the robot can achieve, which means I do not have to program in every time she redoes the kitchen.
Right. Yeah, I don't as far as I know, the ability to generalize like that isn't we're not that far. Where like let's say you're a robot in a room, you got good at building a cup of tea with a certain preference, and then you go transport to a different kitchen that's configured completely differently. It would have to relearn, and the relearning rate of that robot would be a lot slower than a human for sure. And it would have to have someone show it to them, right? Um, and it's this weird sort of paradox. It actually has a name, Maravec's paradox, where those types of like very basic movements are actually really hard to teach, whereas we can build algorithms that play chess better than the best humans can play chess.
Because chess is very, very rule based,
Right.
and
Yeah.
making a decent cup of tea is definitely an art.
Yeah, exactly. Right. If you did that, let's say you just transported one robot who successfully achieved making a cup of tea, transported it to another kitchen, it would take a very long time, I think, for them to learn that.
So almost as if it's doing it all over again because it wouldn't recognize the thing in it.
I don't think it's quite going to zero because
Okay.
it does have like the concepts because well, concepts, I shouldn't use that word because that has a specific connotation. So that was
Well, actually, that was kind of what I was going to say. Do we get the robot with its artificial intelligence to understand the concept of a cup of tea, the
right.
making of a cup of tea?
The concept of making a cup of tea. Right. Yeah. And I think that would be heavily debated actually. Because I guess I would argue that these robots that are learning through experience, they're learning a set of tasks, essentially. I don't know if I'd go so far as to say they understand the concept of making a cup of tea um,
They
in
know
any
that they're doing,
situation.
so they don't really know what it is they're doing. They're doing stuff, but they don't really know what it is that they're doing.
Right. And I think that gets back to what you brought up earlier around self-awareness, right?
Yeah,
Like,
that's yeah, exactly. That's where I was asking around that bit because we tie certain types of intelligence to self-awareness, the concept of the self, and this isn't just human. This is certain animals have this concept of self-awareness. So to some psychologists, that is an inherent part of intelligence. The
right.
the I as a being as a concept.
Right.
And
Well,
yes,
and
okay,
then
we
I
all
think
sit there and go, "Why on earth am I doing this thing?" But that's usually a sign of old age. So
right, yeah, yeah. Well, and I know there's a lot of literature out there around, the concept of AI rewriting itself, right? And just becoming smarter and smarter and smarter, and reaching this level of super intelligence, which means that it's performing things better than humans. Um,
But if it's getting
but that
smarter
would
and smarter
require self-awareness, right? And I
well,
think
and that's kind of
also,
what I'm asking. It's the way you've just described that they rewrite and get smarter and smarter until they can perform tasks. Well, in the narrow sense, they can already do that. Please see chess.
sure.
What you've been saying is you're not sure. Well, we're certainly not there yet on the general, but could we be there on the general side? Do we get genuine super intelligence as opposed to just super specificity? Yeah. Specificity.
Oh, you mean like being really good at chess, for example, means you're super intelligent around chess, but that's you're asking about it in just general. Well, I mean, we don't even it's pretty hotly debated whether we'll ever reach general AI even at the human, let alone superhuman levels.
Oh,
But my
that's kind of
guess
what I'm
is
asking.
like
Do we think we could, or do we think it's like no?
I think there's people that fall on both sides of that camp. I tend to fall on the side of like I don't think we will, but I also really, really hold that very, very lightly because we could. There's a lot of people out there, very, very smart people that I admire greatly that feel that we will achieve general AI. So, um, and then it gets into an interesting space, and I just feel like it's important to bring it up for a second is this idea we touched on briefly around motivation, right? So, what there has to be motivation. Like, even to build programs that make yourself better, your motivation is to be better, right? Is it to be better at a specific objective? Is it to be better? Like that's an interesting question. And there's, this man, Nick Bostrom, who's done a lot of writing in this area, who came up with basically the orthogonality theory, which basically means that intelligence can grow independent of motivation.
So while we're on the motivations, and the different human motivations for different things, a lot of people associate, certainly in the vernacular, that creativity, human intelligence is built in with the creativity and, the motivation to create art.
Hmm.
Now, again, I am loath to carve out certain humans,
Sure.
but depending on your definition of creativity, we're actually alluding to it because, okay, we're not all Van Gogh, and frankly, considering how he lived his life, I don't think any of us want to be.
No kidding.
But that's in creating a piece of art, doing Michelangelo, Leonardo.
Yeah.
Is what we're talking about with general intelligence and the general picking up and adapting. Are we talking about creativity here?
It's a really interesting question. And I've spent, so when I read about, so we built these algorithms that got really good at Go, right? You've brought that up a couple times. And um, interestingly, when it really got a lot of accolades is when it was making moves that appeared creative. Like, and that to me was super compelling because what that kind of said to me, it like made me question what's the human interpretation of creativity? Is it something we haven't seen before? Is it something that doesn't quite intuitively make sense to us, but made sense to somebody else? Was it a spark of inspiration? Because in this particular example with Go, my first thought was, well, they had reasons for it that I can't see, that expert Go players couldn't see. It didn't mean that it didn't have logic or kind of, you know, a reason it got there through, you know, specific kind of um, pathways. And, you know, and it's worth talking about. You know, we have made a lot of headway on things like neural nets, which is basically kind of like a technical application in the field of machine learning and AI that is kind of like a head in the direction of replicating like our neural pathways, right, in the brain, which is why they're called neural networks. And so the idea is that you're kind of, it's learning as it goes. And so that is different than explicit rule based learning. And so, but it doesn't mean that there wasn't a kind of logical way that it went through these. And you can't see inside these things, it's invisible. You have no idea how, in a neural net situation, you have no idea how it got from input to output because it's invisible, actually. But
Okay.
that doesn't mean there wasn't a sort of like um, intuitive, kind of reasonable reason that it got from input to output that was beyond what humans have thought about historically in this Go example.
True, but we've had conversations about music in the past, in that we consider musicians creative, of course, and great pieces of music are extraordinary.
Right.
But there are only so many notes, there are only so many chords, there are only so many chord sequences.
Right.
People put them together in ways that are pleasing to the ear, but there are even only so many instruments. You can hear the same song covered by, arranged differently, but you still recognize that tune. Now, as there are only so many things they can play with, are we saying that that isn't creative? Because
Right.
I don't want to touch that one.
I know it's a hard thing. I don't know. It's interesting. This thing with Go, like it blew my mind around creativity, and I now just feel more confused than actually solidified in what creativity even is.
No, that's fine. We said we wouldn't come to conclusions. We've just
Yeah. Yeah, it's super interesting though. I don't know. Uh, well, and and I noticed too, and this is just on a personal level, not even related to necessarily but you know, there's very human elements to creativity. Like I feel good when I feel like I'm being creative. There's like a positive experience that I have. But, you know, maybe it is just distilled down to I came up with another set of already existing combinations, and that's as simple as it is.
well, it's funny. So I'm got almost the AI experience, weirdly, in that we know my brain doesn't necessarily work the same as a lot of other people's. And at one point, I was known for coming up with creative solutions to, and it's like, that's not creative. You've given me the information. This is the logical solution. This is how it has to be because that's what you've given me. But on the other hand, it was like, I was really creative at seeing through things. Like, no, that's just how that has to go because of this.
Right. Yeah, right. I know. Yeah, so it's almost to me, I know. And so I'm like kind of begrudgingly going in the direction of creativity not even being what I've always thought it to be or felt it to be because of that. Like I'm like feel like I'm like, you know, giving that up in my assumptions about the human experience to some extent, which kind of goes back to your point of is our intersection of interacting with, using and theorizing around AI, redefining the human intelligence, human aspects, including creativity. I don't know.
And it definitely seems to be that it's certainly making us have to think again about what we mean. The
Yeah.
trap we're trying to avoid falling into is carving out humans so that we can say machines are intelligent.
Yes, let's not do that.
On the other hand, there's a lot of people I think will be quite happy if we suddenly claim that an awful lot more animals are intelligent.
Yeah. Great. Well, what a fun discussion, Sophie.
I've enjoyed it thoroughly. Absolutely.
Yeah. Really appreciate the conversation. It's, as you said, we're not making any final claims. This is a very interesting, nuanced topic. And again, for anyone listening, if you're interested in any receiving the podcast or any other content, please click on the link here. And I'll talk to you again soon, Sophie. As always, a pleasure talking.
Thank you very much. As ever, a joy. Bye.
Bye.